Module 9, the peripheral nervous system. The general senses. The general senses refer to the senses that are found in the skin, skeletal muscles, and tendons. So the general senses are the somatic senses. Now there are two types of somatic receptors. Cutaneous receptors are receptors in the skin, and proprioceptors are receptors in the skeletal muscles and tendons. Let's first talk about cutaneous receptors. There are several types of these receptors. The simplest are free nerve endings. These are the most common types of cutaneous receptors. Free nerve endings are just neurons that extend into the epidermis and branch out. These receptors identify heat, cold, itch, and pain. And they're found superficially or deep in the skin. And for each modality or each kind of stimulus, there are different free nerve endings. Another cutaneous receptor type are hair follicle receptors found in the skin. Hair growing out of the hair follicle is wrapped in a receptor. These receptors are kind of like a coiled up free nerve ending. That's why when you slightly tug on a hair, the hair follicle receptor moves and an action potential moves along its neuron. Pacinian corpuscles are found in the dermis. These receptors are pressure receptors that respond to deep touch and vibration deep in the dermis. Ruffini's end organs are also deep in the dermis and respond to skin pressure as well as the stretching of skin. The superficial layers of skin contain Merkel's discs. These receptors respond to light touch, like when a mosquito lands on your arm. Like their name, they are disc-shaped, and many discs are associated with a single neuron. Now, when I say that they are sensitive to light touch, I mean it. They can identify when the skin moves as little as 1/25,000th of an inch, which is why you can identify most mosquitoes because they weigh 2.5 milligrams. The last type of cutaneous receptors are Meissner's corpuscles. These receptors are found all over the dermal papillae, which you might remember are the bumps on the dermis layer of the skin. These receptors help to identify two-point discrimination. This has to do with identifying how far apart two items on your skin are to each other. You will explore this further in the next experiment. Module 9, the peripheral nervous system. Experiment 9.1, two-point discrimination. This experiment, we're going to explore the density of skin receptors that you have in your skin. And the density of those receptors, including the Meissner's corpuscles, help you to be able to determine what kind of touch you're feeling. So for this experiment, you're going to need a helper, someone that you can work with by touching their skin so they can give you some feedback on what they're feeling. What you're going to want to do is you're going to need two toothpicks, and you're going to hold them in your hand in a way that you can control how far apart those points are. And you're going to be able to determine how far apart they are by using a metric ruler. We're going to do this experiment 2 different times. The first time, these points are going to be 0.5 centimeter apart, and the second time you're going to do it with the points at 1.5 centimeters apart. So if I were to do 1.5 centimeters, I would take my measure and I would put this on the 1 and then go to the 2.5. And then let me just show you here, I'm kind of using, holding the ends of the toothpicks with my thumb and forefinger, but I'm using my middle finger to control how far apart they are so they stay at that same distance. Because what you're going to be doing is you're going to take these toothpicks and tell your helper that you're going to be touching them with either 1 or 2 of the toothpicks on various parts of their body. Your helper should be wearing shorts and a short sleeve shirt, so you have access to their skin on their elbows, on their forearms, on their hands, on their knees, on their legs, maybe even on their lower back. You can lift up the shirt and test that part of the skin. And so you will be touching their skin, and you can keep your toothpicks together at the same position and either touch with 1 or touch with 2. And so you'll say, I'm going to alternate touching your skin with 1 and 2 toothpicks, and you tell me without looking whether I'm using 1 or 2 toothpicks. Don't let your subject see what you're doing. And then as you're doing that, just say yes, okay, as they're giving you their answers. Don't say that was right or that was wrong, because you want to know what they're actually feeling, if they're able to identify the 1 or the 2 toothpicks. So you'll go, so say for example, we're doing the back of the hand, and you'll say, how was that? And they'll say, well, it was 1 or 2. How about that? How about that? And you'll just kind of move through the back of the hand. You'll do it again with the palm, and you'll say, how, is that a 1 or 2? Was that 1 or 2? Was that 1 or 2? And your subject will then give you the answer. And so in your lab notebook, you'll be recording whether they got them right or wrong. And you can then identify which areas of our skin have densely compact sensory receptors versus the areas of our skin where they're further apart. Think about that. If your receptors are densely packed together, you're going to be able to distinguish whether that's 1 or 2 toothpicks much more easily because you've got sensors to receive that information. If you have just a few sensors across the skin, you may only feel this distance as being 1 touch. And so that's going to give you a clue as to what areas of the skin have sensory receptors that are closer together. So try this with both distances, 0.5 centimeter and 1.5 centimeters, and then log that information in your notebook. And then you can determine what areas of skin have the denser receptors. Well, now let's discuss the second type of somatic receptors, proprioceptors. There are actually 2 types of proprioceptors. The first is called a muscle spindle. Muscle spindles are mechanoreceptors found in skeletal muscles. They respond to stretching stimuli. So when we stretch out a muscle, we stimulate the spindle. Open up your hand to expose your palm. You are stimulating the muscle spindles within the muscles on the inside of your palm. Whenever a muscle is relaxed and stretched out, either by gravity or by another muscle, muscle spindles identify that. The second type of proprioceptor is a Golgi tendon organ. These are found in the tendons, as the name suggests. Golgi tendon organs identify tension, so when we pull on the tendon like tightly pulling on a rope, Golgi tendon organs generate action potentials down their associated neurons. Tendons are tightened when a muscle is contracted. Therefore, Golgi tendon organs tell you that a muscle is being contracted. So between both of these proprioceptors, our brains know whether a muscle is relaxed or contracted. Well, Golgi tendon organs also give us a sense of body position. So that is why you know without having to look at your foot whether it's flexed or not, or you know whether your knee is bent or not. The proprioceptors give you your sense of the position of your body.